Yeah, my name is Peter Mawio. I'm doing my PhD research on human waste. At this stage, I'm evaluating the applicability of the microwave irradiation technology in the treatment of the human waste. Specifically, I'm looking at the capability of this technology to inactivate ascaris eggs. For our samples, we collect from fresh life toilets that are operated by Synergy, an NGO that is dealing with sanitation in the slums. After sampling, we obtain this waste, and this is what we use testing of our technology. Okay, during the treatment, we use two sets of sample sizes, 100 grams and 200 grams of samples. At the treatment stage, we use two sample sizes, that is 100 grams and 200 grams. So what we do is that we have obtained some spikes of element eggs, like what you see in this tube. We bought this from a certain university that extracts ascaris eggs from human waste. We use this to spike our samples just to be sure that they are ascaris eggs before we do the treatment. And the way we do it is that for each sample size, we have different spiking concentrations. For instance, in 100 grams, we use about 5 mils of the spike, and in the 200 grams sample, we use 10 milliliters of the spike. During the microwave treatment, we use two sample sizes. One sample size is 100 grams, and the other sample size is 200 grams. And because we are not sure whether we have sufficient eggs, ascaris eggs, in this sample, we spike the samples with some element eggs that are contained in this tube. So we use different sizes of spikes for the different sizes of the samples. For instance, for the 100 grams sample, we spike with 5 milliliter of the spike. So basically, we mix 20,000 eggs in 100 grams of samples. But for 200 grams sample, we use 10 milliliter, which is equivalent to about 20,000 ascaris eggs. After we collect our samples, then it comes to the stage of weighing and spiking. And we do weighing by first recording the weight of the beaker, and then we just deter, and then we weigh 200 grams of the samples. So I've spiked with the 10 milliliter. When our samples are thoroughly mixed, the next stage is to put them through our microwave, of course at different times of exposure. For this range of treatment, we are using several time sets of exposure, including 30 seconds, 1 minute, 3 minutes, 5 minutes, 7 minutes, and 10 minutes. So in this case, I'm exposing my sample at 465 watts of the microwave power, and the exposure time is 30 seconds. But basically, for each and every time of exposure and the power of exposure, we use the same procedure as I'm going to show you. So first, I have to do a selection to make sure that I'm exposing my sample at the right predetermined power of exposure. So this is 30%, which is equivalent to 465 watts. But again, I also have to select the time of exposure. So in this case, I select 30 seconds. So first, I take the initial temperature and record it. So I record the 20, and then later we also measure the final temperature, and that we do immediately when our treatment cycle is complete. We centrally place it on the plate of the rotating plate of the microwave. Power and the time of exposure is set, so we simply start microwave, and then we have to be ready with the gun because this time of exposure is really short, with 30 seconds. So I have to be ready with my temperature gun. So 30 seconds are over, so I have to immediately withdraw my sample from the microwave and I take the temperature immediately. Otherwise, I get the wrong readings because the sample is already exposed to the atmosphere. So the final temperature is 30. So I record the final temperature. We cover our waste, the treated waste, with aluminum foil to avoid foreign intrusion and also contaminations. For this second sample, which we want to expose at 70% of our microwave range, which is about 1085 watts. Of course, we take the weight of the sample, which is 200 grams. We spike and then mix it thoroughly to make sure that the eggs are evenly distributed throughout the sample. And as we did in the first sample, the procedure is the same. We put it through the microwave for 30 seconds. The only thing that we do now is the adjustment of the power to coincide with what we have predetermined here, which is about 1085 watts. And for the rest of the samples, we go through the same procedure, save for the changes in the power and the times of exposure. For the same time of exposure, but at different power ranges, we get different temperatures. For instance, in the first sample, I exposed the waste to the microwaves at 465 watts, and the final temperature was about 40 degrees Celsius. But for the 1085 watts, the final temperature raised to about 58 degrees Celsius. So you can see this difference in the temperature when you change the power. When you expose the ascaris to higher temperatures, you also expect different reactions. This is the sample that are prepared to expose at 1550 watts, which is the maximum power. We're exposing at 30 seconds, just as the previous samples, but then we expect changes in the temperature. As you can see, this is the 1550 watts, which is the highest power of exposure in the range that we are testing. And you can see that the final temperature that I'm recording in here is about 69 degrees Celsius. So you see, for the same contact time, we attain different final temperatures as long as we change the power of exposure. After treating our samples in the microwaves, let them cool down while covered with this aluminum foil. When they are cooled down, then we take the final weight so that we also know the effect of microwave on the weights of our samples. The difference in those weights is the weight reduction that we have attained with our microwave. For the 100 grams sample, we use 1 liter beaker as opposed to the 200 gram sample where we used 2 liter beaker, because we want to maintain the same, more or less the same thickness of the sample. The other difference, besides the size of the container, we also use a number of ascaris eggs for spiking. For instance, in the 200 grams, we used 10 milliliter of the spike, but for the 100 gram sample, we have that because we want to have the same concentration. We use 5 milliliter of the sample, which is equivalent to about 10,000 ascaris eggs, which is half of the number of eggs that we are mixing in the 200 grams. So the rest of the procedure is the same, taking the initial weight of the beaker, of course weighing the 200 grams, and then exposing to the microwaves while taking both the initial and the final temperature, and also later on taking the final weight, so that we may know the effect of the microwaves on the reduction of the weight. But our goal is eventually to check the applicability of the microwave in the destruction of ascaris eggs, extraction of the eggs, and also incubating to check for viability. For the 100 gram sample, we treat using the same procedure as 200 gram sample. That's at different times of exposure, so that's the contact time between the microwaves and the waste, and also at different exposure powers. And the power ranges that we use also for these 100 grams is the same as the 200 grams, which is 465 watts, 1885 watts, and 1550 watts. That's the maximum capability of our microwave. Now, after the treatment, besides the ascaris eggs, we also want to evaluate our microwave in terms of the weight reduction. And for that case, we take the initial weight as we did during the initial bits of sample preparation, and then after exposing our samples to the microwaves, we take the final weight. When they are cooled, then we take the final weight. When we subtract the final, the final weight from the initial weight, then we get the weight difference, the weight loss that is, and that is basically the weight that has been lost as a result of exposure to the microwaves. Now, after we've taken the final weights, our samples are ready for the next stage, which is the extraction of the scaries eggs and eventually the test for viability. So what we do is that we transport our treated samples from the collection site here in Kenani back to Mukuru Kwanjenga, where our lab is situated. Now, after the treatment, at the treatment site at Kenani, we bring the treated samples here in the lab for the analysis, for the scaries eggs, and then the incubation. In the extraction process, we do a measurement of about 20 grams. On the extraction bit, we take 20 grams of the sample, of course using the weight balance, and then we mix with about 80 milliliters of ammonium bicarbonate. And the purpose of the ammonium bicarbonate is to both wash the sample and also dissociate the eggs from the debris. So after we've added our 80 mils in the 20 gram sample, then we go to mix the sample in a magnetic stirrer for about 20 minutes. We cover it with paraffin to avoid contamination and also the spread of the eggs in the environment. And then we mix it for 20 minutes. Our eggs are completely disassociated from the debris. Then we do the filtration stage. And at the filtration stage, we use two seed sizes. One is 100 microns, and then the other one is about 20 microns. So we stack them together. The purpose of the 100 microns sieve is to remove the bigger debris, while the eggs are retained, and the eggs and the smaller debris are retained on the 20 micron sieve. The water tends to accumulate on the smaller sieve, so you got to keep watching it so that it does not spill over. You see now the smaller debris and the eggs are retained on this sieve. Then the next stage is to get the eggs back into the beaker. Arrange up the eggs into a clean beaker. So now here we got the debris, the eggs, and a bit of water. So the next stage is to extract the solids part that's going to contain the eggs, and by this we centrifugate the solution at 3,000 revolutions per minute for about 5 minutes. To extract the solids in the centrifuge, we have to transfer the solution into the centrifuge tubes. So now our tubes are ready for centrifugation. We centrifuge our samples at 3,000 revolutions per minute for 5 minutes. This is the end result. At the deposits, this is debris from the excreta and also the eggs. They are entrapped in there. But then we want to get rid of the water because we are interested in the eggs that are already settled in the deposits. So what we do is that we put zinc sulfate in the debris. We mix it well in this vortex mixer so the eggs float on top. So we add the zinc sulfate. Every time we add about 3 mils, and then we mix. Then again we add 3 mils till we get to the 14 milliliter mark. After mixing with the zinc sulfate, just to make sure that our eggs are floating on the top. And this we do by centrifugation again, but this time around at around 2,000 revolutions per minute. Yeah, after centrifugating again, at 2000 revolutions per minute for 5 minutes. You see now there's a supernatant on top of the tube and some deposits. So because we used zinc sulfate in the mixture, we expect the eggs to be floating on top. So the next step is to get the eggs out of the supernatant, and that we achieve by sieving through 25 microns sieve. We gently pour the supernatant through the sieve. So once we have passed the supernatant through the 25 micron sieve, we expect that the eggs are retained on the sieve, together with some little content of debris. Then the next step is to rinse off the eggs into the beaker. So this is the solution containing the eggs. So the next step, just to confirm that they are eggs, we do observation through the microscope. And by this we get about 1 milliliter into the microscope slide. For that we use teat pipettes, and then we cover it with the cover slide. Now this is ready for observation under the microscope. So now we put the slide onto the microscope, and then we put the 10 times magnification for observation. Then now we can already confirm that there are eggs in our extract. The next step is to determine if they are viable or not. So to determine the viability, we incubate the extract that's containing the eggs in the incubator for 30 days at a temperature of about 28 to 30 degrees Celsius. To do the incubation, we need smaller tubes. Then we cover, but we don't tighten completely. And this now is what we put in the incubator. This incubator is set at about 30 degrees Celsius. So leave it in the incubator for 28 to 30 days. But of course, in between, we can do observations to see if there are developments. But ultimately, we want to check if the eggs are developing after 30 days. If they are developing, of course, we know that the range, the power range, and the contact time for sample at the microwaves is not sufficient to inactivate. So we got to adjust. After 30 days of incubation, we take the samples back to the microscope. We observe to see if there is any development. Now, after all that process, we check through the microscope, that is after the incubation of the element eggs, to see if there are any developments. If there are not any developments, then we conclude our microwave technology is effective in inactivation of the eggs. But if we see any developments, then we can easily conclude that set of powers and exposure times that we've used is not effective. Then we have to change the contact times and also the power at which we expose our waste, and then see which is the optimal conditions for inactivation in our microwave units.